Now we will see how to evaluate the limit of the function. Okay, so here there are four problems. So find limit x tends to 0 if it exists. Okay, for the following functions where domain and codomain are the set of the real number. So they are defined as like this. So first we will take the solution of the first one now. Solution of first one. Okay, given that f of x is equal to 1 upon x, x is greater than 0, and 1, x is less than 0. Now you have to evaluate the limit x tends to 0. Now see here, for x greater than 0, there is the function for x greater than 0 is 1 by x, and for x less than or equal to 0, the function is 1. So that means what, for the left and right, the functions are different. So that means what, here you have to take the left hand and right hand limit. For x less than 0, the value of the function is 1 upon x. That means the functions are there are different functions for x less than 0 and greater than 0. So we need to find the left hand limit and right hand limit. So and if the left hand limit and right hand limit exist, then we say that limit x tends to 0 f of x is exists. So first we will find the left hand limit. So left hand limit x tends to 0 minus f of x. So x tends to 0 minus means x less than 0. So we put the value of f of x. So x tends to 0 minus means x is less than 0. So what about x less than 0? The value of the function is what here? So 1. So this is 1. So that means what? Limit of constant is constant. Note that this is 0 minus means it is 0. Only this one, the symbolic representation, whether x is less than 0 or greater than 0. Okay. So this is not minus 0. Okay. This is not a sign actually. Okay. So this is only what? The symbol, left hand limit and right hand limit. So now we'll take the right hand limit now. So this is what? Limit x tends to 0 plus f of x. So limit x tends to 0 plus. So when once you put the value of f of x, so then no need to write the x tends to 0 plus and 0 minus there. Okay, x tends to 0 plus means what? X is greater than 0. So what is the value of the function when x is greater than 0? Is 1 by x. So function is 1 by x. Is 1 by x. So now this 1 by x is 1 by 0. This limit does not exist. This limit does not exist. So therefore limit x tends to 0 minus f of x exists, but limit x tends to 0 plus f of x does not exist. Does not exist. Both should be exist and both should be the equal. Does not exist. Therefore limit x tends to 0 does not exist. We are interested in x tends to 0. We are not interested actually x tends to 0 minus and x tends to 0 plus. But for that we need to find the left hand limit and right hand limit. Does not exist. It does not exist. So the first limit does not exist. Okay. So we take the second one now. We take the second one. Second. Given that f of x is equal to 1 by x, x is less than 0, x is greater than equal to 0. Okay. Now left hand limit. Again we will find the left hand limit and right hand limit. Because what? X less than 0, that is 1 by x, and x is greater than 0, the function is 1. So there are different functions for left hand and left to 0 and right to 0. Okay. So therefore we will find the left hand limit and right hand limit. So limit x tends to 0 minus f of x. So now we put the function f of x. So x tends to 0 minus means x less than 0. So your less than 0 is 1 upon x now. Okay. This limit again does not exist. This limit does not exist. Does not exist. So directly you can say, if the left hand limit does not exist, directly you can say the limit x tends to 0 does not exist. So therefore directly we can write this. No need to find the left hand limit. No need to find the right hand limit now. So left hand limit does not exist. that means this limit does not exist. So therefore limit x tends to 0 does not exist. Does not exist. So if left hand limit or right hand limit does not exist, so then limit does not exist. If they are exist but unequal, then the limit does not exist. If they are limit exists but if they are the equal, then this limit is exist, and value of this is what is the common value we get, that we can write this. Okay. So now again here what, 1 upon x, x not equal to 0, and this is what, x is equal to 0. So again we'll if you take the left hand limit, so this is what, limit x tends to 0 minus f of x is equal to limit x tends to 0 minus 1 upon x. So this is tends to minus infinity, right? And your right hand limit, so actually no need to write this. So directly we can write this is 1 upon x. So this is does not exist. For left to 0 and right to 0, function is same now here. So actually no need to take the left hand limit and right hand limit. So directly we can say the limit does not exist. But in this way you can also write this limit x tends to 0 plus 1 upon x. This tends to plus infinity. Okay. So therefore limit x tends to 0, f of x does not exist. Does not exist. Does not exist. Next, last one, even that f of x is equal to 0, minus 1 less than equal to x, less than equal to 0, 1 less than equal to, not less than equal to, so here there is less than equal to, so this is less than equal to 1. Okay. So here it is less than or equal to, so here there should be the strictly now. Okay. So now again see, x less than 0, your function is 0, and greater than 0, your function is 1. So left to 0 and right to 0 functions are different. So that means that you have to take the left hand limit and right hand limit. So we take the left hand limit. So limit x tends to 0, f of x 0 minus. So limit x tends to 0 minus. So your f of x is what? X tends to 0 minus means x is less than 0, and x less than 0, your function is 0, and limit of constant is 0. So right hand limit. Limit is exists now here, right hand limit. So limit x tends to 0 plus f of x is equal to limit x tends to 0 plus, so this is 1, so limit of constant 1. So therefore what? Left hand limit is not equal to right hand limit. So therefore limit x tends to 0, f of x does not exist. Does not exist. Okay. So this is enough now. Left hand limit not equal to right hand limit, therefore limit does not exist. Okay. So very simple example actually this is. So from this you will get idea how to evaluate the left hand limit and right hand limit. So we'll take the next problem. Evaluate limit x tends to 0 e raised to 1 by x. Now see solution. Let here is equal to limit x tends to 0 e raised to 1 by x. Okay, we know that e raised to infinity is infinity, and e raised to minus infinity is 0. E raised to infinity is infinity, and e raised to minus infinity is 0. Okay, so x tends to 0 plus implies that 1 upon x tends to infinity. X tends to 0 minus implies that 1 upon x tends to minus infinity. Okay, so note that this. So that means what here, if x less than 0, then this is what, e raised to minus infinity we get, right? And if x is greater than 0, then this is what, e raised to infinity. That means what here? So left to 0 and right to 0. So we have the distinct value of the function. So we'll take the left hand limit and right hand limit. So left hand limit is equal to limit x tends to 0 minus 0 minus e raised to x, directly you can write e raised to x, e raised to 1 upon x. So this is what? E raised to minus infinity, and this is 0. Okay. So right hand limit is limit x tends to, so right hand limit x tends to 0 plus e raised to 1 upon x. So this is e raised to plus infinity. So this is infinity. So that means what? Your left hand limit is exist and right hand limit is do not exist. So left hand limit is not equal to, you can say like this also, not equal to this. So therefore limit x tends to 0 e raised to 1 upon x does not exist. Does not exist. Okay. We'll take the next problem. Evaluate limit x tends to 0, 1 upon e raised to 1 by x plus 1. Again see here, x tends to 0 is there, e raised to minus infinity 0 and e raised to plus infinity is infinity. So we will find a left hand limit and right hand limit. Okay. Solution: let L is equal to limit x tends to 0 1 upon e raised to 1 upon x plus 1. Okay. So we will find a left hand limit. So limit x tends to 0 minus 1 upon e raised to 1 upon x plus 1. So directly we can put this limit, because what? E raised to minus infinity is 0. So we have direct value. So we'll take this, because your denominator is not equal to 0, or numerator is also not equal. So this is what? E raised to minus infinity plus 1 upon 0 plus 1. So this is 1. So your left hand limit is 1 now. So we'll find a right hand limit now. So right hand limit. So this is what? Limit x tends to 0 plus 1 upon. So don't write directly. This is what? E raised to infinity is 1 upon infinity 0. Note that 1 upon infinity is 0. Okay. So for that, what we'll do? We'll multiply and divide by e raised to minus x now. Because what? X tends to 0 plus means 1 upon x tends to plus infinity. But and minus 1 upon x tends to minus infinity. So x tends to 0 plus, then 1 upon x tends to infinity, and minus 1 upon x tends to minus infinity. So we'll divide and multiply by e raised to minus 1 by x. So what do we get then? Limit x tends to 0 plus e raised to minus 1 by x. For this product, it will be e raised to 0. So this is 1. Because if you are taking the multiplication of the indices, you know the a raised to n is same as a raised to m plus n, right? So we apply this rule of the indices. E raised to 1 by x into e raised to minus 1 by x is e raised to 1 by x plus minus 1 by x. That means it get cancel, it is 0. So this is 1 plus e raised to minus 1 by x. So this is what? E raised to minus infinity plus e raised to minus infinity. So e raised to minus infinity 0 upon. So we may write this is 0 for your understanding. So directly we can write this is 0. Okay. So therefore what here? Your left hand limit is 1, right hand limit is 0. So that means what here? Left hand limit not equal to right hand limit. So therefore limit x tends to 0 1 upon e raised to 1 upon x plus 1 does not exist. Does not exist. So this does not exist. We'll take a next problem. Evaluate limit x tends to 3 mod of x minus 3 upon x minus 3. Okay, solution. We'll say this is only let limit x tends to 3 mod of x minus 3 upon x minus 3. Okay, so we know that mod of x is x if x is greater than or equal to 0, and this is minus x if x is less than 0 or less than or equal to 0. Doesn't matter because minus 0 is same as 0 now. Okay, now that means what? If x is negative, now see here, now x tends to 3 means what? X less than 3 or x is greater than 3. Okay, so if x is less than 3, then x minus 3 is less than 0. That means this is negative. That means what here? Mod of x minus 3 is same as minus x minus 3. Right? So that means what? Here, if x less than and if x is greater than, this is what? X minus 3 is 0. Then mod of x minus 3, because x minus 3 is positive, this is same as x minus 3. That means what here? This is what? X minus 3 is minus x minus 3 if x less than 3 and x greater than 3. That means what here? Less than 3 and greater than 3, there are different functions. Okay, so that means what? You need to find the left hand limit and right hand limit. Okay, so if your left hand limit and right hand limit is exist and they are equal, then we say that this limit x tends to 3 is exist. Okay, so now we'll take a left hand limit now. We'll take a left hand limit. Okay, so left hand limit. So limit x tends to 3 minus mod of x minus 3 upon x minus 3. Okay, so now this is what? Limit x tends to 3 minus, this is minus x minus 3, because what? X less than 3, x minus 3 is negative, x minus 3 is negative, and mod of the negative number is negative of that one, okay, because x minus 3 is negative, so minus minus negative, it is a positive now. Okay, 1. So this is what? X minus 3, this is x minus 3. So this is what? Limit x tends to 3 minus, so this is what? Minus 1. So value of the limit is minus 1. Okay, x minus 3 get cancelled because x tends to 3, x is not equal to 3, so you can cancel it. Okay, so now we'll take a right hand limit. Right hand limit is what? Limit x tends to 3 plus mod of x minus 3 upon x minus 3. So limit x tends to 3 plus mod of x minus 3. So x tends to 3 plus means x is greater than 3. X is greater than 3 means x minus 3 is positive. So and mod of positive number is itself now. So this is x minus 3 upon x minus 3. So this is what? Limit x tends to 3 plus. So this is 1. This is 1. Okay, this is 1. So value of the limit, the right hand limit is 1. So now the left hand limit is minus 1 and right hand limit is 1. So they are not same. So therefore what? Left hand limit not equal to right hand limit. So therefore limit x tends to 3 mod of x minus 3 upon x minus 3 does not exist. Okay, we take the next problem. Evaluate limit x tends to 0, 3x plus mod x upon 4x minus 3 mod x. Again see here, x less than 0 means x is negative, then mod x is minus x, right? So and if x is positive, then mod x is itself x. So here clearly we have to find a left hand limit and right hand limit. Okay, solution. Let L is equal to, okay, just will write. So left hand limit now. Limit x tends to 0 minus 3x plus mod x upon 4x minus 3 mod x. Okay, so this is what? Limit x tends to 0 minus. Now your mod x is minus x now. So 3x plus minus x upon 4x minus 3 minus x. So this is limit x tends to 0 minus. So this is what? 3x minus x. So this is twice x. And this is what? 4x plus 3x. So this is 7x. So this is what? Limit x tends to 0 minus 2 by 7. So this is 2 by 7. So your left hand limit is 2 by 7. Now we find the right hand limit. Right hand limit. So limit x tends to 0 plus, so 3x plus mod x upon 4x minus 3 mod x. So x tends to 0 plus means x is positive, and if x is positive then mod x is x. Okay, so this is what limit x tends to 0 plus, so this is 3x plus x upon 4x minus 3x. So limit x tends to 0 plus, so this is what 4x upon x. So this is limit x tends to 0 plus, so this is 4, and limit of constant is constant. So right hand limit is 4 and left hand limit is 2 by 7. That means they are not same. So therefore what, left hand limit not equal to right hand limit. So therefore limit x tends to 0, 3x plus mod x upon 4x minus 3 mod x does not exist. Okay, next, evaluate limit x tends to minus 2 plus. So this is what you have to find, only the right hand limit now. So no, here what, no need to think whether we have to find the left hand limit and the right hand limit. Directly you have to find the right hand limit. So we directly solve this. So x plus 3 into mod of x plus 2 upon x plus 2. Okay, so now solution. Okay, directly we start with this is equal to. So now x tends to minus 2, right? That means what, here x is greater than minus 2. X is greater than minus 2 means what, x plus 2 is greater than 0. X tends to minus 2 plus means what, x is greater than minus 2. Okay, so x is greater than minus 2 means x plus 2 is positive. So mod of positive number is itself now. So this is what, limit x tends to minus 2 plus x plus 3 into x plus 2 upon x plus 2. Okay, so this is what, limit x tends to minus 2 plus, so this is x plus 3. So this is what, minus 2 plus 3, so this is 1. Okay, so the problem is over now here. Okay, now next, x tends to minus 2 now. Now we have to evaluate this. Now. X tends to minus 2 minus now. This we have to evaluate. Okay, so then limit x tends to minus 2 minus. Okay, so x plus 3. Now x tends to minus means what, x is less than minus 2. Means what, x plus 2 is less than 0. X plus 2 is negative now here, right? So mod of the negative number is the minus of that one. So you have to write the minus x plus 2 upon x plus 2. So this is limit x tends to minus 2 minus, so this is what, minus x minus 3. Your x plus 2 get cancelled. So this is what, 2 minus 3. So this is minus 1. Again here what, your left hand limit was 1 and right hand. So if the question is asked like this, limit x tends to minus 2, evaluate this one. So again this is does not exist. Okay. Evaluate evaluate limit x tends to infinity root of x minus 5 upon root of x plus 3. So x is greater than 0 is provided to you. So this is what we'll do, limit x tends to infinity. So maximum power of x is half now here. So we'll divide by root x to the both the numerator and denominator now. So this is what x minus 5 upon root x. So x plus 3 upon root x. So this will be what then? Limit x tends to infinity. So under root of. So if you take under root, so we'll divide to x. Okay. So this is minus 1 upon x. Okay. So this is what 1 plus 3 upon x. Right. So directly you can put x as infinity, and we know that 1 upon infinity is 0. So this is what then 1 minus 0 upon root of 1 plus 0. So this is 1. Okay. This is 1. Next. Limit x tends to infinity. X tends to infinity. 5x square plus 3x plus 20 upon 3x square minus twice x. Okay. So now this is what directly we can evaluate this one. Limit x tends to infinity. Maximum power of x is x square. So divide by x square to each term of the numerator and denominator. So what we get? 5 plus 3 upon x plus 20 upon x square upon 3 minus 2 upon x. So 1 upon infinity 0. 1 upon infinity square is also 0. So this limit is what? 5 plus 0 upon 3 minus 0. So this is 5 by 3. Or directly you can write this is 5 by 3. Right? Or directly you can write a coefficient of x square upon coefficient of x square from the denominator. Coefficient of x square from the numerator upon the coefficient of x square from the denominator. Okay. Let f of x is equal to 3x minus 1, x is less than 0, 0, x is 0, so twice x plus 5 if x is greater than 0. Evaluate 1. Limit x tends to 2, limit x tends to 2, f of x. Limit x third, limit x tends to 3, f of x. And limit third, limit x tends to minus 3, f of x. And last one, so fourth one, okay. Limit x tends to 0, f of x. Okay, try to evaluate this one. Okay. Okay, solution. Given that f of x is this. Okay. Okay, so we'll evaluate one by one now. What you want? Limit x tends to 2, f of x. Limit x tends to 2, f of x. Limit x tends to 2, f of x. You have to write the value of f of x now. Your x tends to 2. Means what here? So x tends to 2. Where x takes the value 2 now here. So here what? X is greater than 0. Here x is less than 0. So 2 is not a less than 0. 2 is a greater than 0. So the function is what? Twice x plus 5. Your function value of the function is what? Twice x plus 5. So this is what? 2 into 2 plus 5. So this is 9. Okay. Second now. Limit x tends to 3. F of x. Again tends to 3. Okay. So 3 is what? Greater than 0. 3 is the greater than 0. Less than 3 greater than 3, but 3 is the positive. So where x takes to value 3, here now here. So twice x, again here what? The value of the function is twice x plus 5. So this is what? 2 into 3 plus 5. So this is 11. This is 11. Okay. So third one now. So limit x tends to minus 3 f of x. So limit x tends to minus 3 f of x. X tends to 3, x tends to minus 3. So minus 3 is here. A minus take minus 3 take here now here. So value of the function is 3x minus 1 now here. 3x minus 1. So this is 3 minus 3 minus 1. So this is minus 10. This is what? Minus 10. Next, you have to find the limit x tends to 0. Okay. So this is what? X tends to 0. But see here, less than 0, the function is 3x minus 1. And for greater than 0, the function is twice x plus 1. So that means you need to find the left hand limit and the right hand limit. So we'll find the left hand limit now here. First we will find left hand limit. Limit x tends to 0 minus f of x. Limit x tends to 0 minus. What is f of x? X tends to 0 minus means x is less than 0. So for x less than 0, what is your function? Your function is 3x minus 1. So 3x minus 1. Put x is equal to 0. The value is what? Minus 1. Because what? Put x is equal to 0 here. 3 into 0 is 0. 0 minus 1. So this is minus 1. Okay. So now we find the right hand limit now. Right hand limit. Limit x tends to 0 plus f of x. So limit x tends to 0 plus. So x tends to 0 plus means x is greater than 0. So if x is greater than 0, what is the value of the function? It is twice x plus 5. So this is what? Twice x plus 5. So this is 5. Okay. So now your left hand limit not equal to right hand limit. So therefore limit x tends to 0, f of x does not exist. Okay. So now the problem is over now here. Okay. So we'll take the next problem. We have solved the same problem. We'll take the next problem. Evaluate limit x tends to 0 e raised to 1 upon x minus e raised to minus 1 upon x e raised to 1 upon x plus e raised to minus 1 upon x. Okay. Now see here, x tends to 0. So for this, what we will do? So we know that e raised to minus infinity is 0, right? And x tends to 0 plus, then 1 upon x square tends to plus infinity, and minus 1 upon x square tends to minus infinity. Okay. So this is the rule. But here e raised to minus 1 by x square we cannot do anywhere now here. Okay. So now here what? 1 upon x tends to plus infinity, and minus 1 upon x tends to minus infinity. Okay. So here we'll take a left hand limit and right hand limit now here. Okay. So we have to take the left hand limit and right hand limit. Okay. So left hand limit now. Limit x tends to 0 e raised to 1 upon x e raised to minus 1 upon x. 0 minus, this is 1 upon e raised to 1 upon x plus e raised to minus 1 upon x. Now what is the problem? We don't want e raised to minus 1 by x, because x tends to 0 minus 1 by x tends to plus infinity. This is e raised to infinity. E raised to infinity is what? Infinity. So this is the infinity by infinity form actually. So what we have to do? What we will do? We want minus 1 by x. Everywhere you want to minus 1 by x. So what we will do? We will multiply by e raised to minus 1 by x. E raised to minus 1 by x. To both numerator and denominator. See what happened there? This is what? Limit x tends to 0 minus. So if you multiply with it, this is 1 then. This is e raised to 0 and e raised to 0 is 1 minus e raised to minus 2 by x. This is what 1 plus e raised to minus 2 by x, minus 2 by x. Okay, this is equal to, now we can put x tends to 0. So this is what 1 minus e raised to minus infinity. Oh, we are wrong now here. Okay, so we have to multiply by 1 by x. Multiply 1 by x, because 1 by x tends to infinity. Minus 1 by x tends to plus infinity then. Okay, so we have to multiply 1 by x. This is what e raised to 2 by x minus 1, e raised to 2 by x plus 1. Okay, here we want 1 by x, because 1 by x tends to minus infinity. 1 by x tends to minus infinity, because x tends to 0 minus. Okay, so this you want. Okay, this is correct now. This is minus infinity minus 1, e raised to minus infinity plus 1. 2 infinity is not meaningless, so this is what minus infinity. So this is what okay, so here we will write 0 minus 1, 0 plus 1, so this is minus 1. So your left hand limit is minus 1. We will find a right hand limit now. So right hand limit, so limit x tends to 0 plus e raised to 1 upon x, e raised to minus 1 upon x, e raised to 1 upon x, e raised to plus e raised to minus 1 upon x. Now x tends to 0, 1 by x tends to plus infinity, minus 1 by x tends to minus infinity, and e raised to minus infinity is 0. So you want here e raised to minus infinity. That means you want here e raised to minus 1 by x. You don't want e raised to 1 by x. So what we will do? We will multiply and divide by e raised to minus 1 by x, e raised to minus 1 by x here. Okay. So this is what limit x tends to 0 plus. So this is what 1 minus e raised to minus 2 by x, 1 plus e raised to minus 2 by x. So this is what 1 minus e raised to minus infinity, 1 plus e raised to minus infinity. 1 minus 0 upon 1 plus 0 is 1. Okay, so your left hand limit is 1, left hand limit is minus 1, right hand limit is 1. So therefore what? Left hand limit is not equal to right hand limit. Okay, so therefore limit x tends to 0, e raised to 1 by x minus e raised to minus 1 by x upon e raised to 1 by x plus e raised to minus x does not exist. Okay, so now this is the end of the problem. So this is very nice example of the limit, whether you have to, this is what x tends to 0, whether you have to evaluate how to evaluate this limit by using the left hand limit and right hand limit. So you have to take the care. So you cannot so suppose here there is a x square. There is a x square. So know that 1 upon x square always tends to plus in. So if we have x tends to 0, then 1 by x square tends to x tends to 0 means what? X tends to 0 plus or 0 minus 1 by x square always tends to the positive value, positive infinity. That means plus infinity, right? So that means here that you need the minus 1 by x square then. Okay. So I hope that you understand all these things here, are the problems on the limit. Okay. So now we'll stop here. Thank you.